This video is about the rational zeros theorem, often talked about also as the rational roots theorem. We're using this along with our study of polynomial functions and synthetic division. The rational zeros theorem. If P over Q is a rational number written in lowest terms, and if P over Q is a zero of the function f, a polynomial function with integer coefficients, then P is a factor of the constant term and Q is a factor of the leading coefficient. So, in other words, what we're going to do is to find all the possible rational zeros of a function. P is going to be all the factors that are factors of the constant term of the polynomial. Q are going to be all the possible factors of the leading coefficient of the polynomial function. Let's look at an example. F of x equals x cubed minus 2x squared minus 11x plus 12. A part says list all the possible zeros of the function. So P over Q, the factors of P would be plus or minus the numbers that will go into 12. Numbers that are evenly divisible into 12. So 1 goes into 12, 2 goes into 12, 3 goes into 12, 4 goes into 12, 6, and then 12, of course, goes into itself. So those are all the possible factors of 12. Q will equal plus or minus all the factors of the leading coefficient. Well, in this case, your leading coefficient is x cubed. So the 1, there's an understood 1 in front. So the only factors of 1 would be 1. So to find the possible zeros for the function, we're going to find all the possible fractions we can form P over Q. So plus or minus. And the fact is, if you put all these P values over the 1 in the Q's place, then anything over 1 is just the number itself. So 1, 2, 3, 4, 6, and 12. That's all the possible rational zeros of that function. Now in B part, it asks us to actually find all the rational zeros and factor it into linear factors. So let's just start off with, in the list, let's start off with positive 1. To see if it's a factor or a zero, we're going to see if we get a zero when we do synthetic division. So if I use positive 1, my coefficients are 1, negative 2, negative 11, and 12. So let's run through that synthetic division. So sure enough, we get a 0. So 1 is a solution to the 1 is a solution or a 0 of the polynomial function. Now we have diminished our equation down to an equation that's 1 degree less. So since we started out with x cubed, this now becomes 1x squared minus x minus 12. And it just so happens we can factor that. So if we have 1x squared minus x minus 12, if I were to set that equal to 0, and factor that, let's see, our factors, two numbers that multiply to give me negative 12 but add to give me negative 1. That would be negative 4 and positive 3. I don't actually even need to set these equal to 0. So x minus 4, x plus 3, that's how that factors. So it says in part B, find all the rational zeros and factor into linear factors. So all the rational zeros would be 1, positive 4, and negative 3. So yes, we did need to set that equal to 0. I'm sorry. Forgetting what I'm doing here. Okay? So we got the 1, we got the positive 4 when we set that equal to 0, and then x plus 3. If you set that equal to 0, you get the negative 3. So here are your rational zeros for the function. And it says factor f of x into linear factors. So actually f of x would actually be, since we got a 1, we'd have an x minus 1, an x minus 4, and an x plus 3. That's the factors. Linear factors of that polynomial. In other words, if you were to multiply all this back out, you would get your original polynomial. Let's do one more. List all the possible zeros of this function. So again, f of x equals 15x cubed plus 14x squared minus 3x minus 2. So p will be all the factors of the constant. So we've got a negative 2 here. So the only numbers that will go into 2 are 1 and 2. Now, the factors of q, the leading coefficient in this case is the 15. So 1 goes into 15, 3, 5, and 15. That's all the numbers that will divide evenly into 15. So if we form p over q, the fractions p over q, don't forget plus or minus. If you put all the numbers on top over 1, you would get 1 and 2. If you put them all over 3, you'd get 1/3 and 2/3. If you put them all over 5, you would get 1/5 and 2/5. And all over 15, you'd get 1/15 and 2/15. So that's the list of all the possible zeros for that function. Let's find the actual zeros of the function and then factor our function into linear factors. So in this case, we'll try 1 to start off with and see if the synthetic division gives me a 0. So I have 15x cubed, 14x squared. I don't have any x factor. Yes, I do. Sorry. I thought I had skipped a term, but we did not, actually. So negative 3 and then negative 2. Okay, so bring down the 15 as is. And I can tell really quick that that one's not going to work. So I'm going to erase this. I'm going to try negative 1. Let's see if that's any better. So bring down the first term, 15. 15 times negative 1 is negative 15. So that gives me negative 1. Negative 1 times negative 1 is 1, so that gives me negative 2. Negative 2 times negative 1 is 2. So negative 1 is a solution, or a 0. Now, though, I have diminished my equation down from a cube to a square. So this is 15x squared minus x minus 2 equal to 0. So hopefully we can factor this. I'm going to go to the next page and use to show you bottoms up factoring in case you have forgotten how to do that. We got 15x squared minus x minus 2. Some of you may have forgotten how to do bottoms up factoring. This is a neat little trick. If you take the leading coefficient and multiply it times the constant, you would get x squared minus x, and then that's minus 30 equal to 0. So this is a much easier polynomial to factor. Two numbers that multiply to give me negative 30. But add to give me negative 1. So it'll be negative 6 and negative 5. Oh, positive 5, sorry. To make negative 1. Then divide out the 15 that you divided, that you multiplied again earlier. Let's reduce that. I know x minus, if we reduce 6/15, that would be 2/5 if you reduce by 3. And then x plus 15, 5 over 15 would be 1/3. So the zeros will be 2/5 and negative 1/3. So let's go back there. 2/5 and negative 1/3. There's all of our actual zeros for this polynomial. Now, the factoring actually, though, on this problem, bottoms up, the reason they call it bottoms up is when you've got this fraction here, if you've reduced that to lowest terms, you're supposed to bring that denominator up in front of the x. So the 5 up in front of the x and the 3 up in front of the x. So that would actually make this 5x minus 2 is one factor, and 3x plus 1 is the other factor. So let's go back and list those. factors. It says factor into linear terms, so f of x would actually be, since one of our solutions was -1, x plus 1 is going to be one factor. Okay, the 2/5, that would be 5x minus 2. And the -1/3 would be 3x